Assalamu alaikum guys. I hope all of you are doing good, you're safe and you're sound. Actually, I don't know if you guys can see the steam or the fog coming out of my mouth. It's actually pretty cold out here and I'm also kind of sick. I have flu and I have a blocked nose. So still I'm making this video. Excuse me. So in this video we are going to learn a few topics that are expectation. Actually, I covered this expectation topic yesterday, but I still wanted to uh, give you guys an explanation of what is the expectation of continuous variable because yesterday I explained the expectation of discrete variable, but today we are going to learn the expectation of continuous variable. Then I'm going to tell you guys what is the probability mass function, and then I'm going to tell you guys what is the probability density function and what is the difference. Excuse me. All right. So as I explained yesterday, that expectation e of any random variable or a discrete variable is you take you initialize I equals 1, you take n. Excuse me. So what you put x, I, and f of x. But we did not actually cover the expectation of continuous variables. So for a continuous variable, what you do is you put e of x, capital X, equals, you take the integral of minus infinity. Integral is actually the area under graph. So for those of you who don't know what this is, it's actually the area under graph. Integral is actually the area under graph. All right. So you put minus infinity, you put infinity, and then you put f of x into x and d of x. So this is your expectation or the mean of a continuous variable. Now let us come to the topic of our probability mass function. So if the nature of the variable is discrete, we use probability mass function. So we can write it as uh, p, or f of x equals p, capital X equals 0. Now here this equals x. So here this equals does not mean that capital X equals x. What it actually means is capital X assumes x. So for example, if I throw a coin two times, so I'll have the following sample space. I'll have h, I'll have ht, th, and t. This is my sample space. So for example, if a person is interested in finding the number of tails in this sample point, and you want to convert this variable into a random variable, so we'll have to write uh, for the first sample point, we'll actually put px equals um, 0. Yes, equals 0, and that is 1 by 4. Now for p equals x equals 1, we have actually 2 points where we have one tail, so that will be equal to 2 by 4, which makes 1 by 2. And then for px equals 2, we have one point where there are two tails, I mean, so that will be equal to 1 by 4. And when we'll sum them up, we'll actually get 1. This is the property, because probability of a random variable cannot exceed from 1. It is restricted to be between 0 and 1. You cannot have, for example, if I say you cannot have a 110 possibility, 10% possibility, and the probability cannot also be negative. So you cannot say a person has a negative probability of minus 5% probability. Although we want to use this negative probability thing in our daily life, but in statistical terms, we cannot use it. So this was the probability mass function where where it is a function where a random variable can assume all the values within its data set, and it provides you with the probability of the value it assumes. Now this we use this function when when the nature of the variable is a discrete. But what if the nature of the variable is continuous? For example, if I say that what is the probability of having the probability of having an exactly 5 inches of rain tomorrow. So for example, y is the variable, and I say what is the probability of having exactly 5 inches of rain. So let me actually, or you can, or let me give you guys another example. For example, if I say y is also a random variable, and I say what is the probability of my height having of my height having exactly or is exactly 6 feet and 1 inches. Exactly 6 feet and 1 inches. So let me actually graph it. So here we have 5, 12. Here we have 6. Here we have 6, 1. Here we have 6, 2, 6, 3. And we can assume the probability, I don't know, like 0.9. So let's say this is the curve. So let me ask you, what is the probability that my height is exactly 6 feet and 1 inches? So you guys must be thinking that the probability is 0.9. Is it? No, because it is not. It cannot be 0.9 because the probability of my height having the it is 6 feet and 1 inches is actually 0, because my height can be because I'm not actually sure, because my height can be 6 feet and 1 inches, and then it can range up to 0.000001 inches or 1.000002, or it can range from 6 feet and 0.99999 inches. So I'm not actually sure that is my height exactly 6 feet and 1 inches, or it's a little to the right side, a little greater or a little smaller. So for this reason, we cannot actually take this exact value 6 1 and put it into probability mass function, because it demands from you the exact value. You have to put the exact value of the individual data point for it to find the probability. But here you cannot pick the exact value because you don't know what is the exact value. So for this reason, we actually take intervals. So for example, if I say that x or y should be greater than that what is the probability that y is greater than 6 and smaller than 6 2, smaller than 6 2. So now you have here, you have 6 and you have 6 2, and this is the area under graph. So now we can easily calculate the probability of my height having exactly, not exactly having, is greater than 6 and less than 6 2. The way we can write it as we'll write integral of 6 1 f of x dx. This right here is probability density function. This is actually a probability density function. Or you can change these values. For example, you can say you can denote 512 as 1, this is 2, 3, 4. So for 6 I'll have to put 2. For 6 2 I'll have to put 4. So this will be uh, 6 is 2, and 6 2 is 6, 2 is 4. So this will be like this: 2 4 f of x dx. So this is probability density function. So how do you know if a variable is continuous or if the random variable is discrete? Well, let us cover that topic as well. So the way you are going to know the nature of the variable, for example, if I say that for example if I say or as I explained in the previous topic as well, where there is counting involved, counting, that will be discrete, and where there is measurement involved, that will be your continuous. Now, in discrete variables, you can actually list the sample points, and you can pick exactly one, or you can, and there are distinct sample points in a discrete random variable. But in a continuous random variable, for example, if I say that what was the exact time, what was the exact time, for example, uh, Usain Bolt won the marathon. What was the exact time that he went through that winning rope? So most of you guys will think that's a discrete variable, because most of you guys will say that was, for example, 9.56 seconds or 9.57 seconds. But what if I tell you it's not? Because it can be 9.566, it can be 9.567. So you cannot pick an exact number. The number will have to be an interval between the values. So that was the difference between a discrete and a continuous variable. In discrete, you can list the numbers, and the possibilities are finite. But in a continuous random variable, you cannot pick an exact number. You will have to take intervals. Now, let me also cover this topic, which is cumulative distribution, or you can call it as distribution function. We denote it by capital F of x, and let me also write small f of x, which is probability mass function. So what is cumulative distribution function? It is written as p of x being less than or equal to x. And as I said earlier, probability mass function is noted by p of x equals x, means x assumes x, and here x is less than or equal to x. So for example, let us take this example where we toss the coin 2 times. So here, if one person is interested in finding the number of tails, so in the first sample point, if I put p of x when x assumes 0, it's actually 1 by 4. But for the probability cumulative or cumulative distribution function, when I put p x is less than or equal to x, that will be x is less than or equal to 0. That is also going to be 1 by 4. But when I put p x is less than or equal to 2, so what this actually means is find the probability that x assume a value equal to 2 and less than 2. So that is an interval. You can call it as interval. So x is greater than 0 and less than or equal to 2. This right here is an interval. So what is this going to be? This is going to be 1 by 4 plus 1 by 2 plus 1 by 4. So what's the difference? The difference is in the probability mass function, it demands the exact value. It just demands the exact value, but in probability cumulative distribution function, it demands the value and it's going to give you the probability of that value and also the value which are behind or which are less than the value you specified. So it is going to give you the probability of 2, and also it is going to give you the probability of 1 and 0. So 0, 1 and 2, because it's pointing also towards the lesser numbers, so 1 and 0. So this was the main so this was cumulative distribution function, and that was the difference between probability mass function and cumulative distribution function. I hope you guys enjoyed, and I hope I cleared some confusions from your guys' minds. I tried my best and I enjoyed it as well. Thank you very much.